Want to know how to identify enantiomers, diastereomers, identical and meso compounds. So we'll take those in order. I'll do the RS easy nomenclature in another video because this video would be very long if I consider all of that. So an enantiomer is a non-superimposable mirror image. So a lot of people have problems understanding what non-superimposable means. So I'll give you just the generic definition. What that is that the molecule or molecules cannot be placed on top of one another and give the same molecule. So if you think about it, it kind of makes sense. If you try to put two molecules on top of each other and they don't kind of fit together, then that is non-superimposable. Okay, so I'll give you a pictorial representation of an enantiomer is, and hopefully you can kind of understand what it is. So here's a picture of an enantiomer, and I'll break down, give you some questions that will help you understand. So we have, hopefully you know that this is CH3, and we'll have an OH group. OH, and I'll have the other molecule look something like this, CH3, and here's your OH. All right, here's your OH. So these molecules are enantiomers because you can't place them on top of each other and they fit together. You'll be able to see two different molecules if you tried to fit them on top of each other. So if we break down the definition of an enantiomer, you can ask yourself these simple questions, 4 questions, to figure out if it is an enantiomer or not. So try to remember this. So an enantiomer, we can ask ourselves, does it have the same molecular formula? So same formula. Same formula. And that's yes. These two molecules have the exact same formula. And then you can ask yourself the second question, same connectivity. And to answer that question, yes, they do have the same connectivity. They're each connected here, here, and here, and here. So same connectivity. The third question is, are they the same? Are they the same? Are they the same? And no, they aren't the same, because if you see here, this has a OH group coming out at you. This has a OH group going back into the plane of the paper, if you might say. So the fourth and last question, are they mirror images? Are they mirror images? They mirror images. And that is yes. If you take a mirror directly down here and you face them towards each other, they would be mirror images, okay? They would be mirror images. I'll try to draw a mirror, but they would be mirror images. But the thing is, they're non-superimposable mirror images, okay? So that is the generic, straightforward enantiomer, how you could break it down. It's quicker to, instead of trying to break your brain with tedious definitions, so on and so forth, you could just ask yourself these 4 questions. Are they the same? Do they have the same formula? Yes. Same connectivity? Yes. Are they the same? No. And you could tell because, like I said before, this OH is coming out at you and this one is going back into the plane of field. And so is the same, we could say the same with this CH3 and this CH3 group. This one here is coming out at you and this one over here is going back. And are they mirror images? Yes, they are mirror images. And this is where you need some creativity and try to use your inner child, so to speak, to kind of picture a mirror and two molecules facing each other. So that's the definition of an enantiomer, and this is how you can identify them. Okay, now we'll consider a diastereomer. So I'll erase this, and we'll go to diastereomer. All right, we'll go to diastereomer. And like, try to remember those questions when you're on exams and stuff, because I know it can be very, very hard to look at something and figure out if it's a diastereomer, enantiomer, or meso. So you just try to remember those questions that I had written down, and you'll do good. So now we'll consider a diastereomer. So I'll write diastereomer. So here is diastereomer. Diastereomer. So I'll give you the definition of that, and then we'll break that down, okay? So a diastereomer is an isomer that are not mirror images, that are not. So the key word here are not, okay? So underline that, are not mirror images. Okay, mirror images. So we consider what the definition of mirror images is. So now you know that a diastereomer is pretty much the opposite of a enantiomer. It's not a mirror image. Okay, remember that, it's not a mirror image. So you can ask yourself the same exact questions for a diastereomer. Okay, so I'll break down the questions and then give you an example, pictorial representation. So let's ask ourselves those 4 questions and see if we could break down what a diastereomer is. So same molecular formula. I'll just put same formula. All right, same formula. Actually, I'll have to draw the picture first, and then we can ask ourselves those questions. So I'll draw the picture, and then we could break it down, okay? So here's your picture. So here's your bromine. Bromine here. And I'll have an OH group going back. And then our other picture will be OH going back, and we'll have bromine going back, bromine, and bromine. Alright, so that's our 2 pictures that we'll deduce and try to figure out how this picture is, or these molecules are diastereomers. So, do they have the same formula? It's easy to say that yes, they do have the same molecular formula. They have 2 bromines, 1 OH, and it's a cyclic structure. Okay, so now the second question we want to ask ourselves, do they have the same connectivity? Same connectivity. Connectivity. And to answer that, yes, they do. They do have the same connectivity. There's an OH here, or I'm sorry, bromine there, bromine here, OH here, bromine here, bromine here. So to answer that question, yes, they do have the same connectivity. So the third question, are they the same? Are they the same? Are they the same? So are they the same? No, they're not the same. If you look at the 3D structure, you see that on the left hand molecule you have 2 bromines coming out at you and 1 OH going back. On the right hand molecule we have 2 bromines coming out at us and an OH group going back for bromine, and the 2 bromines on the right are going back and the OH is going back as well. Sorry about that. So are they the same? No. And the last but not least question, are they mirror images? are they mirror? So given the definition of a diastereomer, it says isomers that are not mirror images. So no, they aren't mirror images. And if you draw a mirror kind of down the middle of the molecule, so we're going to draw kind of a mirror down a molecule, down the center of both molecules. So if you try to envision this, if you have two molecules, if you put your hand up to the mirror, and you'll basically have in the mirror your right hand, if that kind of makes sense, when you put your hand up to the mirror. So just think about that when you're looking at these molecules. Both of these molecules, they aren't mirror images of each other. And to like figure that out, I'll kind of break that down for you so you could get a better understanding instead of use your brain and mind. So we'll have, let's take for example this bromine here with the star and this bromine here. So if you look at it in the mirror, you'll have this bromine coming out at you. So that means that this bromine should be what? So this bromine should be coming out at you as well, but it's not, okay? So if you think about that, this OH group right here is going back. So that means that it's supposed to be what? Going back in the mirror, which it is, so that's kind of good, but you have to have the whole molecule be in a mirror image. So if you take a look at this bromine and this bromine, this one is coming out at you, this one is going back. So that doesn't make any sense, okay? So let's now take a look at the identical molecules. So that's kind of easy to break down. The identical, that's simple. So we'll erase this and consider identical molecules. Identical molecules, I have to say, is the easiest one to figure out. If they look alike, then they're identical, pretty much. And you can ask yourself the same questions when you're trying to understand if the molecule is identical or not. Just use those same 4 questions for all of the problems you have to do when determining what the two molecules are. Alright, so try to remember that. So now we'll consider identical molecules, identical. And I'll run through that pretty fast. So identical. Identical is they have the same molecular formula, same connectivity, and they have to be the same molecule, and also they have to be mirror images of each other because they're the same molecules. And I'll give you an example of that as well so you could better understand that. So for with identical, you don't have to ask yourself, are they mirror images? You could just ask yourself the 3 top questions, which are, as I stated before, do they have the same molecular formula, the same connectivity, and are they the same? So to answer that, they should be unanimous yes across the board. All right. So here is your example of the same or identical molecules. So identical versus, and with practice you'll understand this a little bit better and the concepts behind this. All right. So these two molecules are the same, and you could think about that if you rotate this. So let's rotate it. Let's flip this. So if you flip this, if you rotate it, it'll give you that right there. Okay, if you rotate it, flip it, let's say flip this top part. Let me show you so you can understand it. So flip this top part, have this coming forward at you, and this is going to go back. So this is coming forward, and this one is going back. Okay, that will give you this structure right here. So it's the same no matter which way you flip it. If you rotate it 360 degrees, if you rotate it 180 degrees, both of these pictures, it'll give you the same exact molecule. Okay, so hopefully you can understand that Like I said, I was just going to give you a quick, brief description of identical. That should be pretty easy. But if you have a hard time of understanding what molecules are identical, just ask yourself 3 questions. Do they have the same molecular formula, the same connectivity, and are they the same? So, and the easiest way to figure out the last question is rotate one of the molecules and see if it gives you the same 3D structure as the other one. So lastly, we'll talk about meso, which I think is the hardest concept to understand for many people. I think it has to do with the definition of what meso is, but regardless, I'll give you a breakdown of what a meso compound is, okay? So a meso compound by definition, a meso compound is, I'll write meso, let me give you a breakdown of what meso is. So let's go here. So a meso compound is a superimposable and achiral substance that has 2 or more stereoisomers, but it's also superimposable. Okay, so try to remember that. So I'll write the definition down here. Meso is an achiral substance that has 2 or more stereocenters. So I'm sure you know what stereocenters are, and I'm sure you know what chirality is, achiral, so on and so forth. So stereocenters. So try to remember that, and remember the big point here that you want to take away is it has 2 or more stereocenters. So if it doesn't have 2 or more stereocenters, you could quickly neglect the fact that it's a meso compound. All right, so try to remember that. So again, you can ask yourself a series of questions to determine whether or not a compound is meso. So the big questions that you will want to ask yourself is, first, I'll write them down so you can jot these down for future reference. But the first question, you want to identify how many stereocenters the molecule has. So how many stereocenters? How many stereocenters? So if the compound or molecule has more than 1 stereocenter, you can keep going on to the second and third question. So if it doesn't have more than 2 stereocenters, like I said before, you could quickly neglect the fact that it could be a meso compound. So the second question you want to ask yourself is if the molecule has an internal mirror plane. So what that means is any molecule can have a stereoisomer, but not all have internal mirror planes. So the mirror plane should bisect the molecule. So basically what that is saying is when I was drawing the mirror image, it should be symmetric on both sides, okay? So I'll give you some examples too so you can get a better understanding of what meso is. That, like I said before, that one is hard to understand for many people, but hopefully I can do a good job of explaining it. All right, so let me continue writing the question. If the molecule, oh, my spelling is poor today. Molecule, oh, I'm still spelling it wrong. Molecule, there we go. Molecule has an internal mirror plane. So that's the second question. And finally, the last question is, so this third question basically relates to the second question. So if the molecule has an internal mirror plane, you want to make sure that both halves of that molecule are mirror images of each other, are mirror images. Like I said, this might seem confusing. I'll give you a picture and hopefully you can understand that, okay? So I'll give you a quick picture and hopefully we could go with that. So hopefully you got this definition down and the 3 questions that you want to ask yourself when considering if a compound is meso or not. So now I'll give you a picture of a meso compound. Alright, quick picture of what a meso compound is. Alright, using our definitions, of course. So let's go there. Alright, so here we go. I'm going to give you a picture of a meso compound and we can use our 3 questions to deduce this structure here. Alright, deduce this structure. So the first checklist or the first question of the checklist: does the molecule have at least 2 stereocenters? So we see that the molecule surely does have 2 stereocenters. One is right here and one is right there. So for checklist 1, for the question 1, we could check that off, okay? So the second question: does the molecule have an internal mirror plane that bisects the molecule? And yes, it does. So for 2, yes, it does. So what that's saying is bisect the plane. So we could draw a dotted line right down the middle. So in the third question, are both halves of the mirror plane mirror images of each other? And again, that's yes. And I'll redraw the molecule and kind of draw a mirror. Try to envision this. So we have this half of the molecule, and this is coming out at us, and then here's the mirror, and here's the other molecule, and now, so imagine this is facing the mirror and this is the image coming out. So this makes sense. This one is coming out at us and this one is coming out that way at us. So this one is going like this and this one is going like that. So yes, they are mirror images. So for our third question, we can check it off. So this compound is meso. So that is a quick breakdown of how to identify enantiomers, diastereomers, identical and meso compounds. Hopefully you could grasp everything I was saying. If not, you could rewind a video or request additional information. There's tons of information out on the web describing what these compounds are, but this is a general breakdown of what type of isomers they are. So hopefully you can understand the video, and I will leave this up for you for a quick second so you can get an idea. And the best thing you could do is use your imagination. That's the biggest thing with these molecules, because you can't really see them. And when it comes to understanding if they're mirror images, that's where you have to use your imagination.